Okay, so far I've shown you how to use Excel to create a 2x2 table and calculate your measures of association for when you have a cohort study or a randomized control trial. So we also can use the 2x2 table to calculate our odds ratios for our case control studies. So I've just created a new sheet down the bottom here by adding the plus button, and I'll just paste in 2x2 table that we looked at before. Now, with a case control study, we select our participants based on whether or not they have the disease or no disease. So our cases are those with the disease and our controls are those without the disease. So when we calculate our odds ratio, we're calculating the ratio of the odds of exposure. So in this case, we'd calculate A on C is our odds of exposure. So in those who are diseased, and our odds of exposure, so the ratio of exposed to unexposed in our no disease is B on D. So our odds ratio is our ratio of this number, A divided by C, divided by B divided by D. Right, so let's use the same 2x2 table from your example. So this is example 2.5 in your course notes. All right. So in this example, we had 58 lung cancer cases and 95 people without lung cancer, and we measured their exposure. So we want to calculate our odds of exposure. So let's do this first one, A on C on B plus D. You could do it all in one formula, but I think if you're learning how to use Excel, do them in stages. So odds of exposure equals A on C equals B on. So one of the things that people often do is accidentally put it on this total here. So A on the total A plus B, A plus C. So just be careful that you're only using these cells. You don't need a total row at all in a calculation of an odds ratio, but you often need the total rows to be able to calculate or fill in the cells within your 2x2 table. So these are the two odds of exposure in your cases and in your controls. So in this one here, we can decrease the number of decimal points. And then just want to calculate the OR. So the odds ratio equals A on C divided by B on D. Again, we can reduce the number of decimal points and we get an odds ratio of 1.36. So the odds of being exposed in the lung cancer cases is 3.6 times the odds of exposure in those without lung cancer. All right, so now in this lesson, you get to fill in and calculate your odds ratio yourself in your student activity.